Okay, so carboxylic acids and esters are considerably less reactive to reduction, no, because they are the most oxidized form. So the most oxidized actually is the carboxylic acid, then you have the ester, and then you have your ketone, then you have your aldehyde. Of course, the least oxidized is the alcohol. So if you want to reduce to alcohol, no, the most easily reduced is your aldehyde, the next is your ketone, next is your ester, and the next is your carboxylic acid by using reducing agent. So we can easily oxidize, we can easily reduce this aldehyde and ketone, no? So we can actually simply use not so powerful reducing agent like sodium borohydride. But for esters and carboxylic acid, really need to have to use lithium aluminum hydride, a stronger or strong reducing agent. But of course, for the rest, you can use lithium aluminum hydride. But if you use sodium borohydride for esters and carboxylic acids, we cannot actually reduce our esters and carboxylic acid. So lithium aluminum hydride is very reactive with water and must be used in an anhydrous solvent such as ether. And that is one reason why in the conditions when we do reduction with lithium aluminum hydride, our solvent will always be diethyl ether, usually diethyl ether, because again, it's very reactive. It's a very strong reducing agent. If we have that one, we can reduce actually water. No, it's possible. It's very reactive with water, so we don't use water. We instead use diethyl ether. So sodium borohydride is considerably less reactive and can be used in solvents such as water or on alcohol. So I've already mentioned that one. Since it's less reactive, the sodium borohydride doesn't react with water, so it's possible to use water as a solvent. The only one that's very active with water is lithium aluminum borohydride. Okay, very active siya. So again, whenever you have the reaction is very easy to recognize. Whenever you have an aldehyde, like here you have butanol, you have 1, 2, 3, 4 carbon. Can reduce this one to butanol. Like balik na reaction. You have 2 butanol, you can reduce this one as 2 butanol. Now, alcohols can also be oxidized. So again, we have discussed, we have shown earlier, that when we can prepare alcohols from carbonyl groups by the reduction reaction, okay, and you have the reducing agents. Now, aside from katong dimension na to in chapter 11, you can have the substitution reactions of alkyl halide. You can also have the addition reactions of water, and of course your hydroboration reaction, boration reaction to prepare your alcohol, and oxymercuration, demercuration. You can have your alcohol, but it's also possible to prepare alcohol again using your carbonyl groups. You can prepare your alcohol from a ketone. You can prepare your alcohol from an aldehyde. You can prepare your alcohol from carboxylic acid and esters. So let's proceed to the reactions of our alcohol. So similarly, since we can prepare our alcohols from an aldehyde, the reverse can also be true. From the reduction of aldehydes, ketones, carboxylic acids, esters, the reduction process of that to alcohol, we can also do oxidation process of alcohol to a higher oxidized form like aldehyde, carboxylic acids. Okay, so a primary alcohol can be oxidized to an aldehyde or a carboxylic acid. The most oxidized form, as we have mentioned, is always the carboxylic acid. In this case, the oxidation is difficult to stop at the aldehyde stage and easily proceeds to the carboxylic acid. You can actually know this kind of reaction if you are familiar with or observe from the local settings, right? Kat ng mga farmers na to, for example, butong, They can actually prepare suka, no? Usually the suka they prepare, if their source is not synthetic, preparing the suka, the carboxylic acid, the acetic acid, we actually prepare that one from not butong, butong, salubi, no? And they actually do oxidation process. Then you can have your bahal for your aldehyde, and then you can actually have your suka, your carboxylic acid. No, I wish you were able to prepare your alcohols also, or suka. You can actually do that kind of reaction. So this one is an oxidation kind of process, and as mentioned, it's easily difficult to stop at an aldehyde level. You can actually just continue to a carboxylic acid for a 1-degree alcohol. So there is a reagent which stops the oxidation at the aldehyde stage. We call this one is the pyridinium chlorochromate, PCC. PCC is made up from chromium trioxide and under acidic condition. So chromium trioxide, CrO3, and hydrochloric acid. And you have your pyridine. You prepare this, you prepare your pyridinium chlorochromate, okay, from this reaction. And for this reaction, we actually use methylene chloride organic solvent as our solvent to prepare your pyridinium chlorochromate. So you have your pyridinium, it's a positive ion, organic passively charged. You have your pyridine here. You can see the ring here. We still haven't reached the aromatic compounds, but for this ring, it's actually a 6-membered ring. Yeah, the alternate double, single, double, single, double bond. No, but this is just a hybrid structure of an aromatic compound. So, but one of the atom is actually nitrogen, not carbon. So since nitrogen here, it's bonded to, you have 2, 4, you have 2, 4, 6, 1, 2, 3. Yeah, 3 bonds. So 2 bonds. Show now. You have 2 bonds here, if you can imagine. 2 bonds. Shaira, asa man ang uban? Ganina sa inyo, si Kuan. So anyway, you have here pyridine. No, it's a double bond, single bond, double bond, single, double bond, single, double bond. So your nitrogen here actually is bonded to 3 bonds, or would have 3 bonds. You have double bond, single bond here, so 3 bonds and an electron pair, so it's neutral. And in this kind of reaction, actually be protonated, you get your hydrogen. So nitrogen here will be, hindi na nakipakita ang structure, no? I think you can imagine on the structure of your hydrogen. Okay, loading kaya akong laptop. Next. Okay, naay kuan. Di ba naay whiteboard ani? So let's see if we can use the whiteboard. New whiteboard. Let's see if makita niyo akong whiteboard. Kita mo dili.
Makita.
Okay, so okay. So you have your, usually for an aromatic compound, no? Usually you can see an aromatic compound for a benzene ring, kind of like this one. There is an alternating double, single, double, single, double bond, no? Each of the carbon, each of the corner is carbon, and ano siya hydrogen bonded. Okay, that's C6H6. It's an aromatic compound, double single double bond. And there is actually a resonance structure for this. The resonance structure is simply katong, if this is double, no, pwede po diri ang double bond, diri ang single diri. Okay, and in fact, because there is delocalization, we'll discuss this when you reach your next organic chemistry. There is delocalization. In fact, the double bond will be circling all throughout this molecule that you actually have the hybrid of these two structures. You have okay, so each of the carbon, you don't actually, for the condensed form, you don't show on the hydrogen, but you just show on this is the hybrid structure of your benzene. This is your benzene ring. Okay, and for some aromatic compounds, you actually have, instead of carbon, you actually have your so instead you have nitrogen, no? So an I6 member, usually they have 6 members. So you have double, single, double, single, double bond. So each of this is actually carbon is bonded, would have 3 bonds, and the 4th bond is of course the hydrogen, so non-hydrogen. For nitrogen, no, na kay 3 bonds, and they've to follow the octet na siya lone pair. And this one is your pyridine. Okay, so I'm just showing you the one that can you see my slides now? I'm looking. Joke, wait lang ha. Saan pag sharing your screen close up, continue. So I'm sharing now my screen. Okay, so looking back to our slides now, one reaction we have already mentioned na sometimes when we do oxidation of an alcohol to an aldehyde, this is a more oxidized form of your alcohol, sometimes mo-continue ang oxidation at sometimes, but usually mo-continue din siya. And in the usual reaction setting, no, if we don't separate our oxidizing agent to continue sa gina siya mo oxidize further, and I have already mentioned the example na maghimo og suka, no, gikan sa kanang tuba or gikan sa tuba gikan sa lubi. Okay, from tuba, from lubi, tubig sa lubi, you can have your tuba, and you can have your suka, no, tuba, bahalina, pwede bahalina, it's an aldehyde actually. So there is a reagent that actually stops the oxidation of an aldehyde. At an aldehyde stage, you call it one as pyridinium chlorochromate. What happens that you have here your pyridine, it reacts with your hydrochloric acid to have your pyridinium chloride, so nitrogen. So this is just like an acid-base reaction. This is nitrogen having an electron here, so it accepts hydrogen or donates electrons to hydrogen, no, to form a bond here, and you have your pyridinium, which is positively charged, and then you have your chlorochromate. The negative Cl will be bonded to your chromium here, and you have your chlorochromate here, negatively charged. So positive and negative, this is like your whole reagent, PCC, pyridinium chlorochromate. It is ionic, but there is an organic part of the ionic form. Okay, so this is your agent. Once you use this PCC, pyridinium chlorochromate, PCC, of course, in an organic solvent, dichloromethyl, DCM, at 25 degrees Celsius. So you actually get your aldehyde. So CH2OH is an alcohol. You actually get your C bond O hydrogen here. It's an aldehyde. Okay. For primary alcohols, we have already mentioned that the usual reaction would proceed to the most oxidized form, which is the carboxylic acid. There is a usual oxidizing agent, no, for an oxidation process of a primary alcohol to our carboxylic acid, and that usual oxidizing agent is actually the KMNO4. So makabalo mo og oxidizing agent siya because daghan siya oxygen sa iyang structure, no, it actually donates oxygen. Can actually have your KMNO4. It's a usual oxidizing agent. Pag maingon po tag reducing agent, that will be our source for hydride. No, katong mga lithium aluminum hydride, you have your sodium borohydride. Mo to'y source of hydrogen. Mo to nga na ay reduction process na mag-donate siya hydrogen with an electrons with it. The atom that accepts electrons will actually be reduced, no, and the electrons would come from hydrogen. That is for the reduction process, and we have already mentioned it's two types of reducing agent. But for oxidizing agents, usually have your KMNO4, daghan oxygen you can see in the structure. So here you have your RCH2H, your primary alcohol, and a KMNO4. You actually expect to have your carboxylic acid, but before that one, you actually get first the ionic form, the carboxylate, RC double bond O minus with potassium in it, and MnO2, it's a brown precipitate, no? When we do this kind of reaction, we do this in a basic medium and heat, you actually get a brown precipitate, and you do this one, of course, in aqueous solution. And you have here MnO2, and you get your carboxylic acid. Okay, to get your carboxylic acid from your carboxylate, no, it's negatively charged. We need to donate protons sa among carboxylate, no, to be protonated. So we have to do this acidify further, because we started from a basic medium. Once you get your precipitate out, now you have to acidify this one, because this is kind of a salt. You have to acidify this one with an acid. So your hydronium ion. So depending na kung sa imong source of hydronium ion. Then you can have another oxidizing agent. You can have your chromic acid. So this one also stops the oxidation of a secondary alcohol at the ketone. So many oxidizing agents can be used, including chromic acid. So you can see here the conventional O4, it's O4, no? So automatically you can think that will be your source of oxygen for an oxidation process to occur, your chromic acid. Or you can have your Jones reagent, your chromium trioxide here, CrO3 in acetone. It's your Jones reagent. So what happens in this kind of reaction, you have a 2-degree alcohol. Of course, when you oxidize this one, you get a ketone. You don't get a carboxylic acid in this process. So the oxidation of a secondary alcohol will simply be proceeds to ketone lang. There is no carboxylic acid. You see here in cyclooctanol, you can oxidize this one to a ketone. So this part here with an OH will be the one that's being oxidized to C bond O. So cyclooctanol, you get a cyclooctanol. So let's look at on the mechanism of the chromate oxidation. So what happens? So your chromic acid, chromate ester is formed from an alcohol hydroxyl. So how does it happen? So chromium is bonded to 4 oxygen atom, and this kind of mechanism actually is similar also to KMNO4. Similar siya because manganese also is bonded to 4 oxygen. So here we're having an example from a chromic acid. Chromium bonded to 4 oxygen, and chromium is a transition metal. It can accept more than 8 electrons, right? So you have here 2, 4, 6, 8, 10, 2, 2, 4, 6, 8, 10, 12. There's actually 8 electrons surrounding chromium here. And how is it possible? If you remember your general chemistry, chromium has d suborbitals, d levels, no, d orbitals. The d orbitals are a lot of vacant orbitals. Okay, so that's possible for chromium to do multiple bonds or more than 8 electrons because of its d orbitals. So here what happens, chromium now being a Lewis acid. Now there are vacant electrons or vacant orbitals for chromium. It can actually accept electrons from an alcohol. So what happens? It will accept an electron from alcohol to form an oxygen chromium bond. Once it forms an oxygen chromium bond like this one, okay, so we'll utilize the electrons from oxygen to form kaning electrons to form a bond ng chromium, so you get your oxygen chromium bond. So what happens pag form ang bond, one of the pi bonds, no, from chromium oxygen will be converted to an unshared electrons. Once it's converted to an unshared electrons, it will also it will become negatively charged, right? So to disperse a negatively charged, it will abstract a proton from your hydronium, from your acid. So you get your OH and you get this one. So once it's converted to O dot to look unshared electrons, negatively charged, so it will also abstract hydrogen gikan sa hydronium ion from an acid to get your OH. Okay, and what happens is that you have your OH, and here you have also your OH. So duha na ka OH tayo nakita po. And then you have your chromium double bond O and O minus. So you can see here in the structure, same lang siya. You have 1, 2, 3, 4, but 1, 2, 3, 4 oxygen. So double bond CRO, double bond and O minus. And you have your OH, and another OH will be formed here, extracted from your hydronium ion. And of course, you have your chromium oxygen bond. And since oxygen is bonded to 3 atoms, no? Chromium, carbon, and hydrogen here, and an unshared electron, your oxygen will be positively charged. So to eliminate the positive charge, water, the water that is being made from here, no, will abstract the proton. You can sa protonated ether nimo, okay? And what happens is that you will recover on the unshared electrons. So you get now your product. Kani? You get now your product, you get now your product, carbon, oxygen, carbon, without the hydrogen. No, mawala ang protonation ni oxygen here, and you get this one. And what happened is that there is a reversible reaction to this. What happened is that this hydronium, this one can also abstract further, no? It's a reversible process. The OH, since naman siya silingan or the medium is acidic, no, it can actually abstract a proton. OH being having an electron pair, no, it can act as a Lewis space again, can abstract the hydrogen from the hydronium ion to get your OH2, the protonated alcohol. You get this one. Once you get your protonated alcohol, no, what happened is that you do the resonance structure here, this protonated OH. You don't get a protonated OH here, no. Get a protonated OH. This can be a good leaving group. So once it leaves, this one will form a double bond here. So to disperse the positive charge in water, it will leave from chromium. And once it leaves from chromium, this one will form a chromium double bond here. Okay, so you get a molecule of water departs as a living group as a chromium oxygen double bond form. So you get from CR double bond, duha ka double bonds oxygen and OH plus water. So step 2, once you get your this one, what happened is that water can abstract the hydrogen from your kaning carbon. And once it abstracts the hydrogen here, no, it forms a double bond here and leaving the oxygen chromium bond or electrons or bond now will be converted to an unshared electrons on chromium. And what you will get actually is a ketone. So what will be your driving force? An elimination reaction occurs by the removal of a hydrogen atom from the alcohol, carbon, and departure of the chromium group with a pair of electrons. So it will be the driving force. No? Like, why would suddenly water mukalit naman siya abstract kang hydrogen? Of course, we know that water can also act as a Lewis base and can abstract a proton. No nga naman nga, sa daghan din hangan no si water would choose this hydrogen here. We have to remember that this hydrogen is bonded to carbon, which is bonded to oxygen, and here you have a vacant chromium. Now this one is very acidic. Now this one is very highly positively charged. There is an inductive effect. Now you have here chromium bonded to oxygen, bonded to oxygen, bonded to oxygen, no? So chromium would somewhat leave with like a partial positive charge. So to be left with a partial positive charge, the electron density of oxygen and chromium will be directed towards chromium. Carbon and oxygen will be directed towards an oxygen to disperse this very the developed positive charge ng chromium. The carbon hydrogen, no, sa bond tabangan niya because the carbon oxygen is depleted with electron density paingon kang oxygen, no, because trying there is an inductive effect due to the positive charge here. What will happen is that the carbon hydrogen also be directed, the electron density of carbon hydrogen will also be directed towards gang hydrogen, leaving hydrogen to be also partially positive. And because of that, see, water can easily abstract your proton here because this one is very exposed. This one is very acidic. So it's very depleted with electron density because of inductive effect due to the chromium here, which is very positive. And that is the reason why water here can abstract your proton, no, and form your HO3 plus hydrogen ion. And to abstract this one, what will happen? The carbon hydrogen electrons moad to kang oxygen here, because again, you have to remember that oxygen also is depleted with somewhat electron density, no? Okay, there is an inductive effect due to this chromium here. So it will be satisfied by forming a bond between carbon and oxygen here. This carbon-oxygen bond will be, the electrons will be utilized to form acetyl bond O, and the oxygen chromium, the electrons between oxygen and chromium will be converted to an electron density here that is satisfied on the developed positive charge of chromium. And in the process, you get your ketone. So the chromium ion departs with a pair of electrons that formerly belong to the alcohol. Okay, so the general reaction, what is your general reaction here? Here, from an alcohol, you get your ketone. From alcohol, you get your the last step. You get your from an alcohol, you get your ketone. Okay. So the chromium ion departs with a pair of electrons that formerly belong to an alcohol. So amo na gikan kaning gikan diri kuhaan niya og electron si oxygen. And that is the reason from an alcohol gikuha og electron si oxygen na ang electron naadto kang chromium. So for this substrate no na loss, there is loss of oxygen and naadto kang chromium, i-accept ni siya og electron pair, and therefore this one is reduced and this one is being oxidized to have this ketone because this one accepts electrons gikan diri this one is being reduced, this one is being oxidized. So from alcohol to a ketone, this is more the oxidized form. From chromic acid, HCrO4, no, nahimo na lang siyang CrO3H, HCrO3. So reduced form. So always, whenever there is an oxidation, the other agent will undergo reduction process. It's always oxidation, reduction process always go hand in hand. Okay, so here we have an alcohol to a ketone using chromic acid. Similar process actually, similar mechanism you can see with KMNO4. Now let's go for an aldehydes. Now to form hydrates in water. So an aldehyde hydrate can react to form a chromate ester, which can subsequently undergo elimination to produce a carboxylic acid. You have your final product here. You have your aldehyde to have your carboxylic acid. But before that, maagi siya og aldehyde hydrate. So unsa ng aldehyde hydrate? And how does it happen? Okay, so you have your water. Again, your water can be your source of nucleophile. It's electron rich, na siya electrons. And carbonyl carbon is partially positive. So it can actually attack your carbonyl carbon. Once the oxygen from water attacks your carbonyl carbon using the electrons, no? The electron pair kung carbon and oxygen go paingon diri. And then from 2,4 na duha ka electron diri wala gipakita, it will become 2,4,6 naman siyang negatively charged, and you will get your carbon, oxygen, okay, carbon, oxygen, and then apakay isa ka unshared electron diri, isa ka pair of unshared electron, duha ka dot, and then you will have your bond here, kani. Di ko ganahan nga nung magpakita sila, there should be a unshared electrons. Anyway, wala gipakita ang unshared electrons, but know that for this, for oxygen will always have unshared electrons. Pag negatively charged na siya, it means there is 2,4,6 unshared electrons and one bond, covalent bond, and it's negatively charged. Pag oxygen is positively charged na siya 3 bonds and usa ka 1 unshared electron. Duha ka electrons unshared, or one pair of unshared electrons. Okay? So just always remember that electrons will always have electron pairs with it. So once you have this one, it can actually form. This one can actually, the negatively charged oxygen can actually abstract the proton here, no, to get your OH. Okay, this one is a protonated alcohol part here, so it can actually get your OH, can abstract here to get this one, and the oxygen, hydrogen, the electrons gikan diri will return to your oxygen to get your OH, and then you have your OH. So you have your OH. You call this one as an aldehyde hydrate. An aldehyde hydrate is like duha ka OH, no? It's partial mura siya og hydroxylated nga aldehyde. You have here OH. You have an aldehyde hydrate. And then further oxidation, what happens is that we have our chromium. So what happens is that kani, we use this one electrons, the same process that kaning inani, no? Process like this one. We get this process here with your HCrO4 chromate. Now we will attack the chromium using your chromium, using the electrons here, and what you will actually get is your COCr, and then you have your CrOOH, no? And further process, you actually get deprotonate, no? Protonated pa to siya, deprotonate, you actually get this one. So what happens once you get similar po na siya, kaning process, kaning part here, pag abot na nimong ani part, pareha na siya nga part, no? Katong ng alcohol, pareha na siya ani nga part. So step 1. The only difference is kato siya is duha ka OH. Kani siya is ara ka OH. So let's just say isa ra ka OH atong gamiton, no? Itong OH ka ganin din ito balikon. So let's say katong this one is not hydrogen. Let's say this one is OH also. What happens is in ani gyapon, no? The alcohol from the aldehyde hydrate, no, will attack your chromium because this is a nucleophile. Once it attacks, the other oxygen from your chromate, no, will be converted to O, that negative, O, tulo ka unshared electrons negative charge, and then it will abstract the hydrogen from the hydronium, and you get your OH. So OH, na kay OH daan, na kay OH, OH here, and CR double bond OOA. So here, instead of hydrogen, na kay OH. And then the protonated ester here will be deprotonated to get your kani, using your water, kani, deprotonate using your water. Once you have this one, you can actually live. Next will be the OH will be protonated again since it's an alcohol. Pag na siya, it's in acidic form, the OH will be protonated. No? What happens is that once you have your protonated OH, like this one, it actually leaves as a water. And once it leaves, chromium will be depleted with electrons. So katong CO with unshared electrons here will be converted to CR double bond O. Can get here. So you get your OH here instead of hydrogen, get your OH. And then after that one, chromium will leave. No, and you get your OH like this one. It will abstract the hydrogen, and then you will get your CR, C double bond O, this one, OH. Okay, so it will again abstract once you have this aldehyde, will abstract this one, and you get your double bond OOH, chromium OH, you get your carboxylic acid. So you have your water. Once you get your ester here with an OH, you can actually get your, instead of CH3, you have your OH, that one. So the water will abstract your hydrogen here. And the same process gapon, no? Because this one, there is an inductive effect. Chromium here is depleted with electron density because of 3 oxygens here. So there is a partial positive charge here, and the electron density will be directed towards carbon, chromium. The electron density here is directed towards oxygen. And the electron density between hydrogen and carbon will be directed towards carbon because of inductive effect. No, mura bag magtakod-takod ang pagka-positive niya, no? Na din develop kang chromium. And because of that, hydrogen also will be very exposed, very partially positive, that water can abstract this proton here. Once it's abstract the proton, it will be converted to double bond O, get your carboxylic acid. The similar process, no? Except that nakay ang isa, instead of an R group and another R group for a ketone, ang isa ka R is replaced with an OH. But you get actually the same process. Okay, pyridinium chromate reactions are run in a hydrous methylene chloride, and the aldehyde cannot form a hydrate. So you just have to take note when we're using PCC. We run this one in anhydrous, which means without water. Methylene chloride. The oxidation of primary alcohol therefore stops at the aldehyde stage. Balik-balik na siya. We have already mentioned that one here when we are using kani. We always do this reaction in methylene chloride, PCC anhydrous without water, because this one is reactive, no, in water, pyridinium dichlorochromate. If this is in water, it will react with an acid-base reaction. The water can actually abstract this one to get your pyridine again. And you get your, so it don't get your chromate. There's a reaction actually. So you do that one at anhydrous form. So what are our reagents again? In summary, you have your pyridinium chlorochromate. Okay, you have your potassium permanganate. Then you have your chromic acid, and then you have your Jones reagent, CrO3 acetone. So the mechanism using the so far we have already shown the mechanism with H2CrO4, but the mechanism is similar actually with KMnO4, more or less. Now you have your transition metal bonded to 4 oxygen atom, and the mechanism actually is similar. Although naigamay nga difference, because for KMnO4 we do this one in a basic medium. You can take note of this. It's actually done in a basic medium and in water, no, and we just further acidify that one. For chromic acid, we do this one, of course, in acidic medium, And you can see here in the process, no, wala na tayo acidification na final step, no? Kay kani solidified na siya da. You can already have the kani nga process diri ano to. Here, no, we actually have the hydronium ion, no, already forming your chromous acid, not a chromic acid, but a chromous acid, CrO3, not CrO4. Okay. So instead of CrO2, we actually get your CrO3, HCrO3. It's a chromous acid. But for KMnO4, instead, we don't get HMnO3, no, but instead we get MnO2. And you can see on the oxidation state of your MnO4 here, the oxidation state here is +7, and here MnO2, the oxidation of manganese is +4. Okay, so 2, you have oxygen is +4. Manganese here would have an oxidation of +7. So KMnO4 to MnO2 is actually being reduced, but this reagent is being reduced. So this one is called an oxidizing agent. Of course, this one is RCH2OH2. RCO2H carboxylic acid is being oxidized and the other agent is being reduced. Probably I'm gonna ask that one too next time. Okay, so your reagent, PCC, KMnO4, and you have your chromic acid. Of course, you have your Jones agent, CrO3 and acetone. Did we discuss that one? You have there. For tertiary alcohol, alcohols can form the chromate ester but cannot eliminate because they have no hydrogen on the carbon. Yes, of course. Whenever you have a 3 degree